Hello, good day everyone. My name is Afuecheta Stella Maureen, and I'm here to present to you the types of materials being used in stereolithography, short for SLA. Let's get into the slide. So the first material I'm going to talk to you about is the poly 1500 material. Now this material is translucent, not transparent, and it is comparable to propylene because of its plastic-like characteristics. It is very resistant on impact and very durable. Uh, the amount of time this plastic takes to be like when you use it in the SLA, like the amount of working days it will take would be about 3 working days to completely print a small or a kind of project or small project. And it usually comes in 2000 by 700 by 788 millimeters. Now we're going to the next slide. We have the photogene white. Now the photogene white is suitable for general purpose applications. So basically you can use it for sculptures, you can use it for making small prototypes. Also, you can also use it for basically anything is very durable to be used for. It is very resilient. It's a resilient material with good surface quality and thermal properties as well. So going to the next one, we have the next material. We have the TOC XC2700T. Now this material is very transparent, which is good for architectural students if they want to like make a small model of their work and at the same time try to show the inside design of their work. This material itself is very strong, is suitable for a strong water resilient prototype. That means when it comes in contact with water, it will not dissolve or it will not change its physical properties or have some crack or in any form of deformation when it comes in contact with water or leaking if possible. So next is the TOC XC2700W. Now you would understand that the first one we talked about had a T, which stands for transparency, and the one that had a W stands for the white. Like it's just the color or the how the material looks like. It's like a description. Now this is also strong and water resilient and also very good for water resilient prototypes or prototypes in general. Now this is the tarsus. Now the tarsus is charcoal black in color and it has a very high elongation of break. Now we all know the usage of UTM universal testing machines in labs. We had that in one of the classes. So they basically show you how you put the material and then it shows you the strength of the material in form of a graph. So when they put this material after printing it into a UTME machine, it showed the graph and they found out that it actually had an elongated break. Like it takes a long time for it to come to a full break. And that is very good for this material, or it's very good for prototypes or even major planned parts or machine parts that you can just use and replace them. Like you can just draw it in a computer, then put the G code in the SLA, and then you can just print them and then just replace the part. So that is a very good material you can use in the SLA to make prototypes. Also, now we all know how table tennis bat looks like. Now, normally a table tennis bat is very strong, and they use wood being laid underneath before the rubber pattern on top. So this material in particular is very good. This material extreme is very good for very hard if you want to do or make a hard material or hard design. So for example, the lawn tennis, table tennis bat. Okay, so Supreme has a high impact strength and high elongation of break. Excellent um, it has an excellent surface quality. So that means you wouldn't have any problems with, oh, there are flyaways, or oh, there are like bristles everywhere and maybe it's rough. It comes out smooth, which is a very great advantage for this material, and overall an excellent quality. So the next material, which is my favorite material, is the Talk Sumo Solid Grey 3000. Now this material, we see this material in modern day cars. They use it to build the chassis of the car. So the inner layers of a car, they use it to they 3D print it, and they use it to make this shell covering of the car. And it's very amazing because this material is very resistant on impact. So it is very super resistant in such a way that when you hit it on the wall, it will bounce back and not have any breakage, at least to some minor deterioration, like you wouldn't really see any breakage or anything going on. It's very, very like a very nice material if you want to do prototypes that involves cars or prototypes that involves like machines that needs protecting pads over it. This material is a very good material to use on SLA to produce that kind of machine, that kind of prototype. Um, Now, also to print this material, it is said that it takes about okay, it actually how do I put it the maximum part dimension, like the way it comes in, is 2000 by 700 by 788. So that means you need to buy more if you need to do more size or bigger size of parts. Now the next one is the Next. Now Next is extremely durable. It's an extremely durable resin with a high feature detail. So when you want to do um, models or sculptures or a mold of some sort, this material is very good. It shows you like an almost accurate version of what you've envisioned or what you've um, put in the SLA. It comes out really clean, neat, and probably almost exact same dimension and size as you had inputted in the computer or encoded in the computer. So it is very high resistance to moisture as well, and thermal stress or thermal stress. Yes, so that means it doesn't really change or due to temperature change or anything. So the next material will be Reform. Reform is strong, stiff resin with high thermal resistance, suitable for wind tunnel tests or aerospace and automotive applications. Now, before the Sumo material, the Sumo's material I talked about is very similar to this one. Difference between this one um, and, and Toximo is the Toximo is used to it's used for cars, right? But it is heavy. But this material is lightweight and it is also as strong as Toximos. So that's why they use it for aeroplanes and basically automobile because of how lightweight it is. That's like one advantage of this material. And I was watching a documentary on how Dubai largest or tallest buildings are being tested. And I found out that they actually make a smaller model of the design and test it in a wind tunnel. Now, as they're testing it, they need to see how, it probably like this is the best material to use for that small scale model. Because as they're testing it in that wind tunnel, they will have to determine how where they have to cut out in order to make the wind pass through or the air pass through, or how they need to chisel it up to make sure that the sides are like in line with the winds that touch the surface of the skyscraper. So this material definitely is one of the best materials, especially one because it's lightweight and it's very durable, very resistant to both thermal, and it's very very strong. All right, so that's about the materials. Now I'm going to be talking about the applications of SLA. Now I talked a little bit of applications in the materials as I was going along, but I'm going to go into a little bit of detail with like how you can use SLA 3D printing in the world or in real life. Okay, so the first one is manufacturing. Manufacturers automate production process and streamline workflow by prototyping, tooling, and directly 3D printing custom tools, molds, and manufacturing aids at far lower cost and lead times than the traditional manufacturing. This reduces manufacturing costs and defects, increasing quality, speeds of assembly, and maximizes labor effectiveness, which is true. 3D printing, SLA 3D printing reduces the amount of time you put into a prototype or making a prototype. You can do it in less than 3 hours, you can do it in less than 3 days, unlike the regular manufacturing where you have to like wait for months and years for it to be completed. And this is actually very good for those students which are carrying out thesis programs because they don't have to wait for a long period of time to get their thesis ready and they don't have to be delayed. Okay, next. So this is the Masters of Vacuum Casting. So one of the most common uses of SLA parts are masters of silicon tooling to enable replication of parts for various testing in materials that simulate post-modern thermoplastics. The time scale for product development is greatly improved as subsequent copies can be produced within days. Okay, so let me take for example, if I have a model like this, one model right now. Now this model, instead of carrying this model about and going about, I could just 3D scan it. You see that? And I make copies of it. Now, when I make copies of this, it would kind of last. Like I would the same time preserve the the original version of that model, and at the same time still be able to study because I have a 3D printed one. You see that? So that is one of the common uses of this, and it kind of gives you a very realistic or close realistic type of the copies, almost perfect copies of the previous or the original copy. Okay, the next one is education. Now, personally, this is where we benefit from 3D um, printing, especially SLA 3D printing. Uh, we students, we get to see things. For example, during art classes, we don't have to go to maybe, let's say, Paris to see the Eiffel Tower, and then we don't have to go to many cultural centers to see different cultures and different architectures. All we have to do is to simply 3D print it. And when we 3D print it, we can all pass it around in class and look at it and observe it, and we get to understand how it really looks like. That's one of the most important advantages of 3D printing. This is very beneficial to our students, so we don't have to wait hours and money to travel or to go somewhere, we can just see it just from our sit life, how it is on a smaller scale, and we can literally see everything at once. Very, very important. So, education 3D printers are multifunctional tools for immersive learning and advanced research. They can encourage creativity and expose students to professional level technology while supporting STEAM curricula across science, engineering, art, and design, just like how I've explained it. Very important. 3D printing is very, very important when it comes to education. Now, the next one is jewelry. Now, 3D printing for jewelry, I decided to go and see if this is true. And yes, there are wearable arts that are being 3D printed. Take, for example, Black Panther. Black Panther, the queen, Angela Bassett, she wore a 3D printed African lace. It's called an African lace from South Africa. And most of the wears, the dresses they wore there, some of them they couldn't actually like make it right there and there. So in order to save time, they literally 3D printed it and painted it to be close enough to what they can see in Africa. And this really amazed me when I saw Angela Bassett's dress, and the way they explained it, how they were able to mold it and make it was very spectacular. Sorry, was very, very amazed with how it came out. Very neat. You wouldn't even know it was 3D printed unless you were told. And I was so pleased with this. So that's one of the examples for 3D printing jewelry. So the next one would be concept models. So engineering and product design. Rapid prototyping with 3D printing empowers engineers and product designers to run ideas into realistic proof of concepts, advance these concepts to higher fidelity prototypes that look and work like final products, and guide products through a series of validation stages towards mass production. I've explained this earlier and I just said it, like with the example of the one in Dubai. They get to test it with the 3D model first before they can actually mass produce it or build it. So the next one would be medical models. Now, our teacher, Sir Emmanuel, was really raving about how some surgeons actually use 3D printing to know exactly where they need to operate on. And it's very, very fascinating to see that the world is evolving to this very, very amazing place where we can already foresee what we can do or what we're going to do through the help of 3D printing before we can do it on an actual person. So first I'm going to go with dental. Now digital dentistry reduces the risk of uncertainties introduced by human factors. See that? So providing higher consistency, accuracy and precision at every stage of the workflow to improve patient care. 3D printers can produce a range of high quality custom products and appliances to low unit cost with superior fit and repeatable results. All right, so I just like how I explained, imagine operating on someone's mouth and you don't really know how exactly the outcome is going to be like. So of course, the first thing that you would probably do would be to study it first, draw it out first, try to make a cast model of it, which where 3D printing comes in, which is really really important that they actually I really really appreciate the fact that 3D printing is not just used in just one place; it's used in literally in a scale of places, And I am just so really happy to really learn this subject and know exactly how 3D printing can be very beneficial to me in future. Now, the next one is healthcare. Affordable, professional grade desktop 3D printing helps doctors deliver treatment and devices customized to better serve each unique individual, opening the door to high impact medical applications while saving organizations significant time and cost from the lab to the operating room. Just explain that. My prof already explained this, and with the example he gave, I was really amazed, first of all. And last but not the least, I wanted to throw out there, just like in Black Panther, there were also jewelries that were 3D printed and dresses that were 3D printed. For example, Lupita Nyong'o's dress was actually 3D printed to fit her. Now, how amazing is that? Because that dress did not look like something that was printed at all. It looked like an awesome something they just sewn or something like that. But it was really, really amazing to see that. I am somebody that is on the line of fashion designing, and I'm actually a designer, and I make dresses. Not like I make dresses, but I have this keen eye for drawing them. So when I heard that 3D printing can also help in that kind of field, I was really amazing to see what I could actually do with 3D printing, and also in the fashion industry, which is very, very important. Nike have started using 3D printing to do their shoes, to do the soles of the shoe, and other companies as well have started using it to do or put it in touch with some types or some way of material, maybe buttons or something like that. So it saves time, money, and is very efficient. So thank you very much, and I'll hand over to my group mate. Thank you.